example 7 from section 9.7 is very similar to the previous examples. We're solving for the triangle, so we have to find all the angles. We have all the sides, so this is SSS. So we're using law of cosines first to find one of these angles. So we need to find measure A, and the measure of B, and the measure for C. All right. Let's just go for trying to find A, and we're going to use this part of the law of cosines because we have little a, b, and c. We just don't have capital A, and so that's going to look like this. Little a is opposite of angle A, so it's going to be 30. So we got 30 squared. Oof, I'm not going to have room. Equals b, little b is going to be opposite of capital B, so 27 squared plus c squared minus 2 times bc. So 27 and 18 cosine capital A, and that's what we're trying to find. Okay, so let's get the calculator. 30 squared is going to be 900. 27 squared, I don't know that one. 729. 18 squared, 324. Minus, let's see, 2 times 27 times 18, 972 cosine A. Okay. So I'm going to subtract this whole thing right here on both sides. So I get 900 minus 729 minus 324, and that gives me a negative 153 equals negative 972 cosine A. Now I got two negatives here. If I multiply both sides by -1, it's going to make them positive. So I'm just going to make them positive. Now I need to get A all by itself. So we got to divide by 972. Okay. 153 divided by 972 is going to be 0.1574 equals cosine of A. To get A by itself, we have to do the inverse cosine of that decimal. So inverse cosine of the decimal is going to equal A, and that will be .9, because it says round to the nearest 10. So 80.9 is A. Okay, that's using a law of cosines just to get A. Now, do I have to do law of cosines for all of those angles? I mean, that's a lot of work, right? I could if I wanted to, but I don't have to. I could use law of sines, which is a little bit easier to solve for another. Now that I have the measure of angle A. So let's do law of sines. Let's try law of sines. So let's try to solve for capital B this time. If we're going to try to solve for capital B, we're going to do sine capital B on top over little b and set that equal to the a's, because that's what we've got. So sine A over little a. All right? So we've got sine B, which we don't know, over little b, 27, equals sine big A, which is 80.9, over little a. Now let's just solve for sine B by multiplying both sides by 27. Okay. So now we're left with sine B equals 27 sine 80.9 over 30. All right. And now I'm going to solve for this first. So I get 27 sine 80.9 equals that. Divide that by 30. So I have this little decimal number. Sine B equals 0.8887. And to solve for capital B, I'm going to do the inverse sign of this decimal. And that will give me my answer. So inverse sine is approximately 62.7 degrees. That was big, capital B. Okay, 62.7. It's going to write over here, degrees. That's law of sines. Now, do I have to do law of sines or law of cosines again in order to find the measure of angle C? I could if I wanted to. It's a lot of work. Or I could just add these two together and subtract them from 180 because all three angles equal 180. Easy. You can do that on your calculator, easy. So 180 minus 80.9 minus 62.7 equals 36.4. 36.4. Boom. Got it. That was a lot easier than doing law of cosines, law of sines all the way through. But that's using a lot of the stuff that we've learned. Good example.